So we just saw examples where lines were intersecting inside the circles, and we were able to use inscribed angles to solve for missing parts. And so we're going to see if we can do that same thing if lines are intersecting outside of the circle. So if the lines are intersecting outside of the circle, we have our two arcs, one green, that's 34. The orange one here is 108. And let's see if we can use inscribed angles to solve for angle 1. And angle 1 is this angle back here. So again, I can look at this 34 degrees, and here are sort of the end points of that arc. So I already have a nice line created here for me, so I am just going to draw another line. And remember, our rule for inscribed angles is that it is half the measure. So half of 34 is going to be 17 degrees. So this little angle up here is 17. And if you notice, I sort of made a triangle. I'll highlight it in pink. I made this big triangle right here. And so let's now use this 108. We can see that we also created, by just drawing that one line, we've also created an inscribed angle right here. So half of 108 is 54. So I'm just going to redraw sort of the situation that we have going on right now. So up here we have our 17 degrees, here we have that angle 1, and here we have 54 degrees. As I mentioned in the last video, if you remember your exterior angle theorem, that this outside angle is going to equal the sum of these two angles. So we can say that the measure of angle 1 plus 17 degrees is going to equal 54, and then we can subtract and solve. So the measure of angle 1 is going to equal 37 degrees. So we looked at that was one situation. Oh, what am I doing? So that was one situation where the lines were meeting outside of the circle. In that situation, it was two secant lines. In this situation, we have two tangent lines. And so let's see if we can still use our inscribed angles to help us solve this. So what we can see here is we have this piece of the arc is equal to 243 degrees. And so I'm interested in finding this piece right here. So I'm going to take 360 degrees because there are a total of 360 degrees in a circle. And I'm going to subtract off that 243 to get that this piece right here is equal to 117 degrees. So that pink arc or purple is 117 degrees. So similarly, what we've done before is we can create our inscribed angles. This one looks a little strange, but if I connect these 2 points, what you've actually done is created an inscribed angle. So it's kind of hard to see, but I can consider this and that to be an inscribed angle capturing that arc of 117 degrees. So our rule here, again, is to divide by 2. So 117 divided by 2 is going to give us 58.5. So the cool thing about this one is that if you remember when two tangents meet outside of a circle, that these lines are congruent. So we can actually say that this is an isosceles triangle, this triangle that I have created right here. And so we know that if it's an isosceles triangle, that the base angles have to be congruent. So this angle down here is also 58.5. And so now we just want to solve for angle 1. And so we can subtract 180 minus 58.5 minus 58.5. And when we do that, we should get our answer, which I believe is 63 degrees. And then finally, we have a situation where we have a secant line and a tangent line. So remember, the secant goes through the circle, the tangent just touches at that one tiny little point. So here sort of is where it's touching. So again, we want to see, can we use inscribed angles to help us solve for angle 1? So here we have our arc sort of being captured here, and here is at 67. So if I draw this line right here, I've created an inscribed angle that's capturing this arc right here, which is 67 degrees. So remember, half of the arc is equal to the angle, the intercepted angle. So that's going to be 33.5. I now also have this angle here, which is capturing this arc, which is 119. So if I do 119 divided by 2, that's going to give me 59.5. And similar to that first situation that we looked at, ooh, not a great drawing, but it will do. Here's our situation, and so we can use exterior angle theorem again to say that the measure of angle 1 plus 33.5 is going to equal 59.5. So when we subtract 33.5 from both sides, we should get that the answer here is going to be 26 degrees.